anybody know Bald Rock? That's good, because this slide was actually taken in New South Wales, and my heading is Queensland. Queensland, you can see Queensland, and it's right on the border. I have 26 gnammas, of which 24 are in Queensland and 2 are just over the border. One is only a few metres away from the border, and this one is about 50 metres. Now I'm talking about gnammas, and gnammas are holes in rock, not formed by a rock that's swirling around in the river bottom, but by rotting, usually in granite, sometimes in sandstone, sometimes in laterite, and sometimes in a few other sort of rocks, but it's mainly granite. And there are 4 major types: pans, which are shallow petri dish type things, pits, which are lovely pudding basin shaped. They're always in granite. Pans can be in sandstone, granite, limestone, quite a few things. Armchairs are quite rare, they're on the side of rocks, and pipes are out in the desert, particularly the Gibson Desert, where I'm going again this year. The other side of Uluru, over to Kalgoorlie. Anyhow, we're interested in pans here. Now, pans then are these lovely shallow petri dish shaped things, found mainly on the horizontal surfaces on the tops of exposed rocks, and they're formed by weathering along laminations, and this is why I bought this bit of rock for. This is a lamination that's happened because of a bushfire, and the rock gets so hot on top that it splits off from the rest of the granite mass, or it just sits there, and if you look carefully you can see a few little bits there. So the water rots along these laminations, and you get a pan, and that's a map of, not that pan, but some other pan, to show you that it's basically a petri dish. And in it the water will persist for weeks to months, particularly in WA, in the wheat belt, with the winter rain. But things are a bit different at Stanthorpe. But first of all, this will convince you of the laminations. So here's the gnamma floor, and here are the laminations. And they form naturally by heating and cooling that's pretty hot, 45-degree days. And the top bit of the granite will split off, and then that makes a weakness, and the pan will form. And this is the essence of my talk, because this doesn't happen at Stanthorpe. It's not that hot. The pans up at Stanthorpe are quite shallow. They're only 6, 5, 4 centimetres deep, with a couple of exceptions. There's no laminations, and all the weathering occurs at the water, air, rock interface, and you get a C-shaped curve where all the action is. A little bit happens on the bottom, but not much, except when it's just drying. So these pools are quite shallow up at Stanthorpe, and so the hydro periods are short. And this is tough for the animals that try to live there, unless you have a lot of rainfall or low evaporation in winter. Okay, well, as I said, I've got 26 gnammas up there. Some of them are on Carol's place. Carol and her partner out the back of Stanthorpe, and Carol's now become my lieutenant, and as you'll see a picture of her later. And these are Carol's gnammas there, and we've mapped them with a drone at 1 centimetre intervals. It's too busy, we're going to change that to 2. And this is the one we're going to concentrate on. This is Esme's pool, which is a 2 centimetre contour map of it. Esme's pool is a whole 7.5 centimetres deep, which means it's deeper than most of the others, and so we can do a little bit of work on it. And here is the Stanthorpe country with these Inselbergs, which are island mountains, and on top of these, this is where you find these gnammas. And this is our best one, Billy Goat Hill, and that one's actually 20 centimetres deep. It's a 15-metre climb, it keeps you fit going up and down. And here's our map of it, once again done with a drone. And as I say, it's a little unusual because it's 20 centimetres deep, and that will feature a little bit in the talk. And here's another one, which is on near Bald Rock, just in New South Wales, And it is different. It's 9 centimetres deep, but it has lots of organic matter in from the trees, and that makes a bit of a difference too. All right, now this is an important bit of information here. I've been studying these things right across from Western Australia to Queensland, and been doing it for about 10 years. And I've done a lot of work in WA. And at the top row you can see the average pool depth for a number of rocks, I think from about 50 rocks, the same with the Eyre Peninsula. And I've just finished Central Victoria, it's just been published, and the granite belt's not published yet, but you can see there's a big difference in the average depths. I do give some ranges there. Go right down to the bottom line now, pool momentary species richness. So this is when you go and you sample and you get a number of species and you identify them all. And I go 5 times, so over 3 years, so you get a cumulative species richness. But here you can see the big difference between Western Australia and the granite belt. And the pool cumulative species richness is also very poor in the granite belt. The Inselberg species richness is the whole big rock. In Western Australia there's hundreds of these pools on the rock. So you've got lots of opportunities for species to be present. I mean, not every species is present in every pool. And so the Inselberg species richness, 60 in WA, say wave rock at Hyden being one example, which has been very well studied. And only about 15 in the granite belt. And then you can go up to the aerial species richness, and once again Western Australia shines because it's a huge area across the wheat belt of WA. The Eyre Peninsula is a lot smaller area. Central Victoria, there's a lot of area without granite, so it's a bit hard to get an aerial thing for that. And then the granite belt in Queensland. So that gives you some idea that it's a bit rough in Queensland. You can't have many species because the pools are not very deep and the hydro periods are short. Let's have another way of looking at that. And this is a graph of species richness against the maximum pool depths, and you'll see that most of the pools, we didn't do anything less than 3. We probably should have done because we wouldn't have got anything, or hardly anything. And the deepest pool was 9, and then the next deepest pool was 20. But unfortunately, you get a nice graph like that, but I don't believe it. It's beautiful. Let's see the next thing, I think. The correlation coefficient is highly significant, but it's only based on 26 sites. And the real problem is that the pools marked X have trees next to them and lots of organic matter in them. You can see that the deepest pools have a lot of organic matter in. That gives a much more heterogeneous environment, lots of dead leaves and places to hide, and so the species richness goes up. So, but also you should realise this graph looks as though it goes upwards, but it doesn't. It plateaus off. So I don't think I'll be publishing that. It's based on some spurious information. All right, now let's have a look at the main species that are present. Is clamshred Paralimnadia urukhai, a lovely little beast. It's the iconic species for the ones at the granite belt. It only lives on the granite belt. I've looked for it elsewhere into New South Wales and haven't found it, except right on the border. I'm going to talk a fair bit about it. And then there is a chironomid, which is found right across southern Australia, and a biting midge, both pictured there. And they are cryptobiotic, which means that when the pond dries up, they just shrivel up in the bottom mud and just sit there, nothing happens, and when the water comes back, they rehydrate and they start moving again and develop, and away they go. So that's a fantastic adaptation for living in this sort of habitat, to be cryptobiotic. The shrimp doesn't have that. And then there's mosquitoes, where you know mosquitoes breed everywhere, so there's at least 2 species, there could be more, but they're certainly the ones we kept getting all the time. And there's a little beetle which is a very widespread beetle. So they're the 5 species, or 6 species if you like, which are the main species in these pools. And then some less common ones, planarians, which are the predators. When the pool dries up, they have a wonderful time eating all the dying things. Bryozoans, and I've not had bryozoans in any of my other pools across Australia, only in the Stanthorpe ones. I don't know what they are. Water flea, there's only one species where I have quite a few of them in WA and in South Australia, and a few in Victoria. There's a beetle, some nematodes, an ostracod. I normally have more ostracods, but they're pretty rare in Queensland. Then there's the raries, a large ciliate protistan, a dragonfly in the bigger pools, various emipterums in the bigger pools. BGH is billygoat hill, various beetles, a snail, a mayfly, and Coronis teperi, all in billygoat hill. So that you can see immediately that billygoat hill has a high species richness. It's 27 compared to only 6 to 8 in the normal shallow pools. So there just isn't room for too much. I want to talk more about the life cycle of the clam shrimp Paralimnadia. On the right's the female, and on the male we've undressed one of them, so as you can see his anatomy. And here you'll see that he has 2 claspers, well actually 2 on each side, so that's 4. And the claspers are used for holding the female. Not so much for mating, but for mate guarding. And this is the mate guarding, where the pair go around together for a few days. And he's just waiting for her to molt so that he can mate. And mating's not such a big deal for us anyhow, because they don't have any gonopods. The male has no gonopod, the female has no gonopore. Their testes are along the trunk, and the ovaries are along the trunk there. And they have little pores, and they sort of ooze sperm. And I've not seen it, but apparently he's able to pass those sperms somehow forward into the female, and they go into the ovary and fertilise the eggs, and then she lays eggs, which are species specific in their shape. And here are some resting eggs. There's probably some bacteria on these ones. This is all done with a scanning electron microscope at the Australian Museum. And these eggs, as I said, are species specific, and they come in all shapes and sizes. Some of them are star shaped, some of them are barrel shaped. Most of them are roundish with some sort of polygonal structure. This one has a groove structure. And they sit in the bottom mud, in the dried mud, for weeks, months, years. And then when the right conditions come, they hatch, and they grow very quickly into adults. All right, we're just a little bit up at Stanthorpe. There's 770 millimetres is the rainfall at Stanthorpe, which is one of the highest rainfalls I've ever had right across Australia, to have 770 millimetres. But the evaporation's high, particularly during summer, and there's no months in the year when the evaporation is less than the rainfall, although it is lower in the middle of winter, which is very helpful. And in summer, on very hot days, Carol, I'll mention Carol and Mark in just a minute. We've seen that the evaporation rate is 9 millimetres a day. So a pool that's only 6 centimetres deep, you can imagine, doesn't last very long. And one that's 3 centimetres deep is gone in 3 or 4 days after rain. Just gone. All right, well, here's my assistants. Now, these are citizen scientists. Carol here is counting the animals, and she has these sticks she puts across, and she goes across and counts them across the pond. This is Esme's pond, and she does that 3 times and gets a figure. And you're going to be amazed that she can count 40,000 of them. I don't know how she does it. Counting 1,000 is possible, I reckon. Here's our depth stick in the middle of the lake. There. We've got a curve for the volume of the lake. This is all mapped by Justin, and we've got a volume curve at any depth, and so we can work out the volume of the pool very accurately. And Mark, he takes photographs of 30 animals each time, and then he measures them at home on the computer. And so we have very accurate measurements of the lengths of the thing. And the measurements usually, and I'm going to show you some graphs soon, but there's no standard deviation, standard errors on it, because it's all less than about 2%, except in one case where it's more. But generally, the animals, they all hatch at once. Then they all grow up in a generation. It's called a univoltine life cycle, and then they start dying. All right, well, here is the life cycle at Esmos during the low evaporation period, which was May to August. We had one continuous filling, but with many different rainfalls. In fact, it was a little bit dubious at the beginning, and the thing almost dried up, but luckily we had more rain. We do this in the middle of the day because early in the morning, these beasts don't like the cold and they all sit in the bottom mud and you can't count them. So you have to wait till they get swimming during the middle of the day. So it's all done between 12 and 2. And they're the daily temperatures. So the winter temperatures were 15, 20 odd. All right, so hatching. When they started this, they couldn't count more than a few thousand. So here are the numbers, and the numbers drop very quickly. The lengths go up very quickly and then very slowly. So they grow in a matter of maybe 12, 15, 18 days, and they're adults. And then they can reproduce away as much as they can. Every few days they lay a batch of eggs, and here are the number of mate guarding, so that's some indication of their reproduction. And this is this terrible thing that happened here. Not quite the right dates, but only a few days apart, when they gave up mate guarding because the place had just about dried up on them. It was down to about 15 millimetres deep. But they got back into their sexy ways again and started laying more eggs. All right, so they produce lots of eggs during winter. And that's just as well, because during summer, and we haven't finished yet, we're on our 5th cycle during summer. And so you get a rainfall, and the best ones are probably this one here, where there's a big storm, 40 odd millimetres, and the depths just go, it starts off at 70 millimetres, and then it just dries up very quickly, not so much from that storm. This is another series of storms. This was a beauty, 70 millimetres of rain in one storm, and we had a huge number. In fact, let's see, didn't I put it in? Oh, sorry, still coming up. We had pool temperatures around 35 degrees, even up at Stanthorpe, during the 12 to 2. The pools rained, it slowly, and the pool filled up slowly. And that's interesting, because as you're going to see, the numbers over here grew slowly. And also, the standard deviations were high. We had, they were all one generation, but they hatched at different times as the pool started to fill, and this lot hatched in the deep pool, and then it got a little bit more, it hatched here, and then it got right up full and it hatched up there. And so we had a real mixture, whereas normally it fills in one go and they all hatch at once. So this is what happened here. So here's our numbers, here's our mate garters, and we had 41,000, I don't know how Carol counted all that. And there's a little bit of variation in that, and we're still waiting for them all to die off. They all died off fairly quickly because the pools dried up fairly quickly. And the interesting thing is that this generation here didn't produce any eggs. This generation here didn't produce any eggs. This generation here didn't produce any eggs, although they mate guarded for a little while. And this one here produced just a few, and we don't know what's happening here. They probably won't, because the place is drying up so quickly. So during summer, they are wasting their time. They're exhausting the egg bank. Although there's plenty of eggs there, they don't all hatch at any one hatching. And obviously, they're not adding to the egg numbers, but it's hard living there at Stanthorpe. Okay. There are clam shrimps in gnammas all over Australia, And we didn't know this until I started on my quest over the last 10 years. And we don't know the life cycle of all these things. We've just been able to work on where's this one here, Paralimnadia urukhai here. It was described in 1979 by two geologists. So we're learning a little bit about that one, but look at all these ones we don't know about. The interesting thing is that compared to other countries in the world, we have far more in gnammas than anybody else. And in Australia, maybe this is a good place to live because they do fill most years, and they fill either in summer in the north or in winter in the south. And in Stanthorpe, they're filling both winters, both because Stanthorpe's between the north and the south. And yes, I've got some of them up in the north. We don't know much about these ones up in the Kimberleys and the Pilbara and so on, or on Uluru. So there's lots of stories to find out there. And finally, I've been looking all over the area to find out how far. And this is in the Gibraltar Range National Park. And yes, there are gnammas out there, except that's a 7-kilometre walk and then you've got to climb a mountain. So I've only ever been there once. It was a terrible day. It was in October. But I got clam shrimps, and they're a new species. They're not going to be described yet. And I've been to Torrington. Anyone know where Torrington is? Torrington's northwest of Glen Innes, so it's inland. It doesn't get enough rain, and the pools are no more than 3 or 4 centimetres deep, and there are no shrimp because it's just too much for it. We haven't counted eggs, full stop. It's a big job, and we don't know. All we know is that they produce a batch of eggs about every 3 to 4 days when they reach that maturity level at about 15, 18 days. And they probably the egg bank in this place is probably quite high, quite concentrated, and they just hatch out over summer but don't produce any more, don't add to it. We can see them through the carapace, and I've had a look at all these pictures. These two citizen scientists are really organised, you know. They're fantastic. Mark's a former engineer, and so he's really organised, he's got it all worked out, and there's a huge picture bank, and I can look through them all and look for eggs. The pH of these pools is about 6, by the way, and it varies during the day. It goes up to 6.5 and drops to about 5.5 overnight. But as the pool gets shallower and shallower, the pH gets lower and lower, because no doubt you don't have the big water mass there to work against all the CO2 that's in place. So I thought it was pH getting too low, because the pH goes down to 3.5 as the water level's about this. They don't like the really cold because they sit in the bottom mud doing nothing. Right. And it gets quite cold at Stanthorpe. As far as we know, the pools don't freeze. They might when they're only this deep, but when they're like this, they're not freezing. But I was surprised, they get 35 temperatures during the day. And they're quite happy at that.